Okay, all right, it's back. Okay, so before we start, can I get a show of hands, like who's a web developer in here? That should be everyone. Unless you're trying to make the switch from back-end or something. This is definitely a front-end technology. And did you come for, wait, no, sorry. I don't really have any good icebreaker questions. Okay, it's 1:37. I think we'll just start. I think everybody from lunch should be here by now. All right, well, there's some movement over there. All right, you made it just in time. Okay, so welcome. I hope you survived the 3 days so far pretty good, and you know, props for you for still standing on Sunday afternoon. You guys are warriors. Okay, so this talk is about Polymer, but you know, the new, which is basically a library for web components that Google is promoting right now, and everybody's doing presentations about Polymer right now, so I thought I had to get a little bit like a twist on it. And since the company I work for is called Pandas, and we really like pandas, I figured I'd do my Polymer talk with the help of some cute pandas, because you know, who doesn't love pandas, right? If anybody in this room doesn't love pandas, I need you to leave right now, by the way. But I assume because it was in the title that I assume because it was in the title that nobody who doesn't like pandas isn't even here, right? Except for that smart guy over there. All right, so just a quick outline, what you can expect from this talk. First of all, I'm going to talk a little bit about what why do we want web components, so what are they and why do you want them, what's the problem that they're trying to solve, and how do they do that. Then I'm going to talk about Polymer, why you would want to use something like Polymer. This is actually, it shouldn't just be why, it should be what, why, and how, kind of. So what, why, and how Polymer, what is it, how does it work, why do you want that, why do you not want just straight up web components. That'll be the Polymer intro. And then in the end, I'll show you a little bit of a case study of a project that we did last summer with Polymer. We actually built a whole project with it that's online and it can be used. And we did it with a preview version of Polymer and live to tell the story. So hopefully I'll have enough time to get into that. First of all, a little bit about me. I'm a Panda. I work for a company called Pandas. I've been coding since about 2008, and first with Java and Spring, and that was pretty horrible, I gotta say. Then with Ruby on Rails, which was slightly better, and then it started getting painful, and so then I switched to Node and CoffeeScript, and we'll see, that might, you know, it looks like I have about a year left, and then it'll be horrible and painful. But anyways, I've done a lot of front-end work since then, actually, when I did the Java stuff. JavaScript is, in fact, the language I know the longest. Because that was, I didn't list it here, but that was there all the time. I did all this front-end stuff with XJS, starting like when I did this Java program. Anybody used XJS before? I think they're called Sencha now. Has anybody used it? It's sort of like Windows Forms for the web or so. It lets you build UIs that look exactly like Windows. Okay, but so first of all, like a little bit to set the scene. You know, I'm going to give a little bit of a background of what, you know, the story. You might be familiar with it, but I want everybody to be on the same page about the history of basically front-end web programming. 1995, right? JavaScript came out the first time. I think everybody knows that. So that's 20 years now. with Netscape Navigator 2.0. And of course, right away, people started using it. Oh, we can make like image rollover effects. We can, add a little bit interactivity to our site, right? There's still basic HTML pages, but now you have a little bells and whistles over here. And basically it's wild, wild west in front-end land at that time, right? Everybody's it's all free for all. There's JavaScript, that's it. There's no framework. You can do whatever you want, and you'll probably fail at some point, right? Because it'll break on this browser and that browser. IE3 comes along, nothing works, and so on, right? It's a time of lawlessness and folly. Everybody just, does whatever works, and when it doesn't work, they cry, and then they try again and figure out something new. You're really supposed to laugh at these right now. This is the funny part, okay? Like the hard part comes later. I'm trying to I'm trying to trick you into this coming along, because afterwards we're going to look at code and it's not going to be funny anymore, I swear. Maybe it'll be enlightening, right? But it won't be funny.
It's not going to be a WAP moment?
No. I mean, that would be stealing, right? The wheel is being reinvented again and again in JavaScript land. Everybody cooks their own stuff, right, and starts from scratch, and you share like little snippets of code and stuff like that. But overall, it's pretty terrible, right? Until about 2006, then jQuery came along, and finally some sanity started to come into JavaScript land, right? Finally, somebody showed people how to do it right, how to really how to make DOM manipulation simple and portable and make it work in all browsers, and finally you get some front-end code that works in all browsers, and not just it works except for IE or except for Netscape, right? So along with that comes a new paradigm that everything is a jQuery, right? jQuery always returns jQuery, right? It's I think the smarter people say that's a monad, right? So every time you do a jQuery, out comes a jQuery, so you can chain and you can do all this stuff, and everything just returns a jQuery. It's great, right? Because you never have to think about it. You always know you can just chain another thing on the end. So that's awesome, right? It's also the rise of the so-called jQuery developer, right? People that actually learn a front end before they learn the language. So they'll say, oh, I'm really good at jQuery, but what's JavaScript, right? Anybody ever met one of those? Of course, there's plugins, right? jQuery has plugins, which are really great because you can actually use them and reuse them, right? So you can actually do like things like a date picker, and you actually only have to solve it once, and then you can put it online and other people can use it and they don't have to do it again and again. So it actually has a standardized format to exchange those snippets, and it makes building sites a little bit easier, right? Before you kind of had to like pray and probably rename a bunch of variables and stuff, and now you can just use a plugin and then off you go. Except, of course, that plugins aren't really, there's no real encapsulation for plugins, right? That means once you start using a lot of plugins, which is what everybody did, of course, right? I want a date picker, I want a calendar, I want a type ahead, I want a image rollover, I want all these things, right? So, soon enough, you get into this problem where one of your CSS classes is already being used by another plugin, right? And then you have to rename them all. Anybody ever got that problem? Yeah, you know what I'm talking about, right? So after a while, really, it starts to become a hairy mess as well, because you get further, you get more shit done, and then it starts becoming a hairy mess, because now you can't just use the original distribution. You have to patch your plugin every time. Then when you update it, you have to do it again. So there must be some way out of here. This is what some people started thinking, right? How do we fix this? How do we make this better? How do we get rid of this whole? How do we provide strong encapsulation on the front end and components that you can share and still make it easy to distribute and use them, right? Okay, so what they thought was basically, okay, so HTML already has built-in stuff for interactivity, right? This is what we've been using all this time for all our web apps, right? We have drop-downs, right? We have checkboxes, radio buttons, like basically form elements, right? Now with HTML5, you get a couple more, like a date picker, but it isn't that pretty, right? It's not particularly nice, but it's there. So that stuff was already built in. Unfortunately, right, it's only up to the browser manufacturers to decide what kind of interactivity we need, right? What if I really need some special type of input, something, a signature field where I draw with my mouse or something like that, right? There's always some kind of interactivity that makes sense for one person or some people, and maybe not for a lot of others. So it doesn't make sense to ship all of that in the browser, right? Even though the browser can now play videos, record audio, record video. It can do. It can actually. There's actually an API to read out the ambient light sensor on a Mac that decides whether your keyboard turns on and off. I bet you didn't know that, right? It's part of HTML5. But the idea is, so how do you, is there a way that we can use this built-in stuff, right? Like use extend the concept of having elements with powerful interactivity and make it generic and make it extensible so that people can package their own form elements, their own elements, provide the same interactivity, and make it reusable, right? So what they said was this, basically. They looked at these elements and said, okay, what's the common thread here, right? All of them have a user interface. Well, most of them at least, right? The form elements we looked at, they have some sort of user interface that has some interactivity. They have interactivity. I can do something with them. They can interact with the page. They can generate events, right, in JavaScript. They have properties in JavaScript that I can read out. And that way, my JavaScript code can interact with them. The user can interact with them. I can read out the information in them. And also, they can be configured. So some of them have attributes that I can use to change the behavior, right? I can make a select box can be a drop-down, or it can be a multi-line select box. And if it's multi-line, it can have a single selection, or it can have a multiple selection with control pressed, right? So I can change the behavior to an extent, to the extent that the browser manufacturers were able to standardize within the framework of HTML, right? But the idea behind web components is really how can we make this, and how can we make this so people can ship their own elements, extend the browser in an almost native way, but without having to ship any native code, right? Microsoft's answer like 10 years ago was ActiveX, right? And that was terrible, right? Because, I mean, it was great because you had all the flexibility, and then you had all the security issues along with that, right? Java didn't work out either because it just takes too damn long to start to run a JVM just to have a rollover button effect, right? I remember seeing those. It's like, really, do you need your rollover button effect so badly that it must take 30 seconds for me just to wait until your plugin initializes and the JVM is loaded? So what if we could write our own HTML elements, right? Our own HTML elements and ship them along with our site and maybe share them with other developers. And they can extend HTML in the same way, sort of like XML was supposed to be, right? Like write your own tag. But we can actually encapsulate the functionality and the code that makes it happen. And that's what Web Components basically is, okay? So Web Components is an API. At the core of it is an API that allows you to write your own implementation. So that allows you to register new HTML tags and then write your own implementation for them. Your own, you can tell it how it should look like, how it should behave, and the logic behind it. Okay. So web components is the spec. So that's like HTML. It's just a specification, right? HTML, HTTP, that everybody agreed on. That allows you to build those custom elements. And it's currently in progress. I think it might be finished by now. And it basically gives you standardizes the APIs that are used for browsers to allow you to build this interactivity. The core technologies, and we're going to take a quick look at those. This is the web components intro. There's custom elements, shadow DOM, and HTML imports. And I'm going to give you a real quick overview of these, so you know how they work, how they fit together, and how they make this whole thing work. The first thing is custom elements. What that allows you to do is just tell the browser, tell the HTML parser really, here's a new tag, right? And I'm going to tell you how it works, right? So it allows you to register new elements with the parser, and this code shows how it's done. So what we have to do is we create a new object with a HTML element prototype, and then it provides a callback for us that is called when that element is created, when it's inserted into a page and loaded. And then you can call document.registerElement and to register that element. That will make your browser recognize it. So the way that works is actually the browser will read the document first, right, and parse it, of course. And every tag that's in there that it doesn't know, by specification, it's supposed to assign a class of HTML unknown element. And of course, it has to parse everything first because it won't see your code otherwise, right? But then after it sees you registering those elements, it will go back and look at the elements that are HTML unknown elements, and then it will see if you provided an implementation for them. And if it did, it will upgrade. It's called upgrading, right? So then it will upgrade your element, and it will reload it and attach your own prototype to it. Now, in that prototype, your own prototype object, right? So in that prototype, now you can attach a bunch of methods to it. You can attach event handlers to it, and so on, right? And all of that will be run as soon as your element is upgraded. And this is a demo down here, basically, of what's going on here. This is all the next slides are going to look like that. Yeah.
What does this do for page performance as far as like load time and DOM parsing?
The parsing, I actually don't know the exact technical data for that. I didn't implement it, but the parsing shouldn't take any longer, right? Because that's the already existing specification, just unknown element, and later on, upgrading might take a little bit, but the goal is for this the specification. The point of the specification is so that browser manufacturers can implement this in native code, so it'll be reasonably fast. There's a polyfill provided for it that allows you to run this on browsers that don't do it, but that's rather slow, right? This implements all the APIs in JavaScript. And it works, but it's not that performant. But once it's implemented in native code, it should be reasonably fast. Okay, now we get the shadow DOM. That's basically a mini DOM for custom elements. What it does is it provides you your own little piece of DOM inside the page DOM that's private, right? So like an object orientation, right, where you have your private variables and nobody can mess with it. Your shadow DOM is basically your own private little DOM that isn't affected by the outside. So that means it's actually immune to style changes from outside. You can use any IDs or classes in there. You can use any IDs, and they don't have to be unique within the entire document, just within your shadow DOM. They won't conflict.
Can I ask quickly?
Yeah.
Should you think of this shadow DOM as a branch in the main DOM or sibling?
Yes.
Parallel to
Right.
the main DOM? Which
right. As a branch.
Okay.
As a branch. So a shadow DOM can be attached to any element. You don't have to do it with custom elements. You can write code and attach shadow DOM to regular elements if you want to. And it can be manipulated, right? Like it has the same API. It's like literally like a clone of the actual DOM in terms of API and everything. It's just it gets attached to one element and provides and gives you a space, basically like a sandbox to mess around in and display your own stuff, and it will be shown in the document, but it won't be affected by the styles. It won't be affected by the JavaScript running outside. It won't bleed any CSS outside. So inside your shadow DOM, you can load your own CSS, and that CSS won't affect the CSS outside. It will only affect it inside of the shadow DOM.
Could it be found by a jQuery, for example? If you query it by the custom element.
It doesn't have. I don't think jQuery has a selector for it. But if you
Yeah, but if you just get by the element name.
yeah. So you can try and you can find an element and then you can query and see if it has a shadow root attached to it.
Question here,
Yeah.
is this shadow DOM independent of the actual DOM? Separate from the DOM?
It's a sub DOM.
So how could,
It can't exist without the actual DOM, but it's a small DOM within the DOM, like a Russian doll.
how do you control the overall layout?
How do you? The overall layout is by the rendering engine, by the overall DOM. So the shadow DOM, if it has visible elements in it, will appear where the element was supposed to appear. I'll show an example later. Okay. This is just showing how to do it. So here we just query an element, and then we attach a shadow DOM. That's just the API. I'll show later how this looks like. And then the final ingredient that we need is HTML imports. Okay, and that basically lets us import HTML documents into other HTML documents. And the reason why you want this is because a custom element will have usually three components. It will have HTML, which is the view, right, which is the structure of what it looks like. You have CSS, which is how it's supposed to be displayed, and you have JavaScript, which is the behavior, right? And all three can be embedded into HTML. So HTML is the obvious choice for container format. And so what a HTML import lets you do is just like an import in your programming languages, right? Import this or import that. It lets you it tells the web browser, I'm going to need that other page too, but don't display it, just load it. So when the browser sees this, and this is done using a link tag, right? So when the browser uses this link tag, sees this link tag with rel equals import, what it's supposed to do is it fetches that document, that HTML document, it parses it, it runs the JavaScript code inside of it, and then it attaches the resulting DOM of that to I think to the shadow DOM of this link tag. So now it's loaded, it's available within your page. The JavaScript code has been loaded, the CSS has been loaded, but it's not shown anywhere, it's not displayed, right? Just like when you import a class in Python or Ruby or so, right? When you run the import or require or whatever it takes, that code is loaded, it's parsed, it's ready to use, but it isn't used until you use it. So it's the same thing, but for HTML, right? And then you can access it like this programmatically in JavaScript. There's a .import property that will be available, and that will give you a reference to that DOM. So you could manually, what you could do is manually extract things out of it and put them in your page, but there's a better way, and we'll see that. So now finally we get to Polymer, right? Polymer is really just a framework around these technologies to make them easier to use, right? You saw, like, it's not really that much of a pleasure to create a new document by hand. I mean, a new element, right? You have to do, .create element, then you have to register the shadow root, then you have to, right? Then you have to bundle everything up, use HTML imports. So Polymer makes all of this a lot simpler for you. Right? It lets you, first of all, it lets you create your elements declaratively, right? So no more, you don't need to use document.register element. You can just do, you can just declare your, it actually, this is funny, you will see, it actually lets you use custom elements to define custom elements, right? It lets you map events declaratively and even declarative layout. So it's basically declare all the things, right? But that's not even all. It actually also it has polyfills for old browsers. That's called Web Components.js. So that's I mentioned this already. It provides you, right? It lets you run your pages in older browsers with performance hit, but it'll run. It also comes with a component library, so you don't have to start from scratch. Google actually provides not one but two libraries. One core elements and then paper elements. So the core elements are basic interactivity. They're pretty plain, and you can style them. There's paper elements, which that's basically implementing the new paper look and feel that Google is rolling out across all of their apps and platforms right now. I don't know if you've seen the new Google Maps app and the new inbox that supposed to replace Gmail. So that look and feel, that's the paper elements. So Google provides a whole library, so you can build something that looks like Google. They even have a UI designer that runs in the web browser that lets you kind of drag and drop, choose from a whole panel of elements and drag them on your canvas, resize them, inspect their properties, and so on. But we really want to learn how to do it by hand, right? We're not that lazy. So, okay, so how do you do this? How do you do all of this with Polymer? Okay, so I told you Polymer lets you use custom elements to define custom elements. And this is what it looks like, right? So, first of all, you want to import Polymer, right? So you use an HTML import and import the Polymer element. What this does is give you the custom element, Polymer element, which you can then use to create your own custom element, right? So this is a custom element, as you know. Oh, but I forgot, by the way, all custom elements, this is part of the specification, have to have a hyphen in the name. So if you do document.register element and you use a name that has no hyphen in it, it will create an error. That won't work. So that's actually surprised nobody asked about namespacing. How do you prevent people from re-implementing link A or re-implementing already existing stuff, right? Basically, custom elements have to have a hyphen in the name. That's how you can tell if something's a custom element. No HTML element has a hyphen in the name. All custom elements have hyphens. So a Polymer element, and this is the name, so this will have to have a hyphen in it, right? And here we use an attribute called noScript, which means we don't have any logic attached to this. This can be used for logicless tags that are just supposed to provide some sort of UI to it, like some sort of embellishment. And then inside there's a template tag. This is HTML standard, right? It's HTML5 standard, and then the contents of that template tag will be in the shadow DOM. So when I load this tag, and then when I use it in the site, what I will see, here we go, and this is how we use it. So here's a simple HTML document, right? That actually makes use of this custom element. So you saw in the custom element I didn't load the polyfills, right? Because the idea is if I can load a custom element, obviously my browser must understand how to use custom elements. But if I use it in a page, right, then I have to ensure that that my browser will know what a custom element is. So the first thing you want to do is load the web components polyfills, right? That makes sure your browser won't choke. Now this implements HTML imports, so now we can use them. So we can link to Polymer. We want to load that first, and then we link to we import the element, the custom element that we just wrote. And then inside the body, You can just use it like a regular element. And then what will happen, of course, right, since the template specifies that to happen, it will show an H2 with, hi, I'm a custom element, right? And you see that it's just inserted in the body. This is live text. This is a live preview. This is what it looks like. So where you would expect that my element to show on the page, it will show that element's shadow DOM. If the shadow DOM is, well, larger than 0 pixels, right? So if there's nothing in it, then nothing will show up. If there's something in it, it will try to fit it in there with the size that the shadow DOM says it wants, right? So if I have text in there, H2, right, the browser will figure out how big is that text, how long, and then it will show it if there's enough space in the document. Yes?
How do you eliminate prevent flash of unstyled content?
Good question. There's a tag. Actually, the Google way or the Polymer way is there's a special attribute you can put on the body, and what it'll do is it will actually turn the page white, and then it'll wait until all the elements are upgraded, and then it'll fade in.
Oh, cool.
Yeah. So, and that actually usually doesn't take very long, like split second. But good question. Yeah. Otherwise, you're right. Otherwise, it would start showing, and then you'd probably see flickering until all the elements are upgraded. So now Polymer also gives us data binding, which is nice because if our custom element isn't very useful if it just shows the same damn headline all the time, right? Gets a little bit boring. So probably what we want to do is maybe be able to change that, right? So instead of having a fixed text here, now I can just I can use the double mustache syntax and put a variable name here, and then now I have to use actual logic, because now I have to define a prototype of my element and define that property so it can be shown, right? And so the way that works is now I have to put some JavaScript in here. And I use the Polymer, I call Polymer to register the element. The first thing you want to do is provide the name of the element so it can be matched with this element. And then the second argument is just the prototype. So the whole object that goes there will be the prototype, or will be merged with the prototype of your tag, right? So now on the tag's prototype, I can access that in JavaScript. On the tag's prototype, there is a greeting property, and if I change it, actually try this. Oh crap! I forgot how to access the thing inside the shadow DOM. All right, if you're interested, I can show it later, maybe. There was a trick to it. I haven't done it in a while. All right.
I can see that the
Yeah.
syntax is shared between Angular and this Polymer. Is there any kind of synergy between Angular and Polymer in the sense like they share the templating engine?
Yeah, I actually haven't used Angular, but I hear, first of all, I hear Angular directives are pretty similar in Angular 1.3. What I also heard from some people at Google is that the direction is that in Angular 2.0, Polymer is supposed to replace directives. So this is supposed to be a replacement for it. This might be why the syntax is familiar, because they want to make the upgrade path easy. So we can also have custom attributes on our elements, right? So we can that way we can actually specify the greeting in our HTML markup, right? And the way you do that is simply there's an attributes attribute on the custom element definition, and that lets you specify the names of the attributes. So this is actually you can put several there, just space separated. And all the names that are in that will be made attributes on your. So it will configure your element to accept these attributes from the DOM, from the HTML, right? And once the element is loaded, it will be instantiated, and those attributes will be set as properties on your DOM. So they will carry over, right? So the way I've shown this here, actually, you see I have a default greeting here, and then I have attributes greeting, right? That means if I use my element without greeting, it will show the default. Value here, and if I do provide the greeting attribute, it will show that instead. So it will override the default. That's how you provide defaults for attributes. And finally, we have event mapping. So inside of our little shadow DOM world, right, we want to be able, right, this is our own world, right? You have your own document in there. You can do any effects that you want. You can put anything in there that you want to have. And so, of course, that wouldn't be very useful unless the user can interact with it, unless we can build new ways of having the user interact with our page, right? So, so now we want to react to events. And the way you do that is basically you just define it in the DOM of your element, and you use the double mustache syntax again with the name of a function. That should be on your prototype, and it will, and Polymer takes care of the rest and makes sure that your function gets called, your event handler gets called when the event happens, so that you can react on it, right? So I can click on here and say, my name is Panda, and then it changes the greeting, right? So that's how we interact with it.
So even though it's changed, you can still click on it again, right?
Yeah, yes, even though it's changed, that's what the code says, right? I can click anytime, right? So I can say SCaLE, right? Yeah. So everything in a mini DOM, it works just like a regular DOM, right? The only difference is now you have your own little private play place. You can do in there what you want. You can use your own IDs. You don't have to worry about them being unique. They just have to be unique within your mini DOM, right? You can use your own CSS. Doesn't have to be unique. It won't override anything outside of your mini DOM. You can use your own JavaScript. You can, right? Everything is encapsulated. You don't have to worry about overriding anything outside or changing anything outside. All right, and finally, they also, this is a bit of a goodie. It doesn't actually have to do with custom elements, but since Flexbox is finally standardized as well, Google thought, oh, it might be nice, because now, HTML with components sort of becomes like and Flexbox sort of becomes like a language to also lay out applications, right? So you want, flexible layouts to adapt to any screen size, right? Where you can, you want to be able to arrange things predictively on a page. But I don't know if anyone here tried to use Flexbox so far in CSS? Two? What do you think?
It works, except I was using WebKit.
Yeah.
Version, not the newer version.
It's pretty gnarly though, right? I mean, the stuff you have to put on there, it's rather messy. I mean, I tried a little bit, and you usually have to combine like three different attributes on the CSS class to get something.
It's not much different from like doing CSS table layout.
Okay. I guess you've done more CSS than I have. I've always hated it. I'm not like the layout kind of person. I like to code.
Sometimes I'm a masochist. But
Yeah, I think you have to be with CSS. I think you have to be. Well, this makes it really easy. So basically, it lets you use attributes on HTML tags. It's basically just the whole CSS solution, right? So obviously you can just select this with CSS, right? So it's really just an extra goodie CSS library, but it's pretty fun, so I thought I'd show it off. So if we have a div and we say horizontal layout, right? Layout is the tag that activates Flexbox, so that means inside of this div I want Flexbox layout, right? And then horizontal means the elements, I want the elements to be arranged in a horizontal manner, right? So that will put the correct flexbox tags on it so that the elements show in that manner. And then I can just put in my diffs in here, right? And then they're arranged like this. This is a live preview. There's no extra CSS in there except for, except for the color. So I added a little bit of padding and a background color. And otherwise it's the same HTML. You can make elements take up more space by putting flex on it, right? So I can make that middle element take up all the remaining space by putting the flex attribute. You can use several flex elements and use a ratio in between them, right? So I can do flex 1, flex 2, flex 3, and then they will be flexed in that proportion. And when I resize, they will adapt and stay in the same proportion. And okay, I guess that's all I have about Flexbox right now. There's more stuff, right? So obviously we can arrange them vertically. Don't have enough space to show that. We can justify elements. We can have them all left or right, center, and so on. But I think at this point you probably really want to see something that's built with Polymer, right? And how that code looks. All right, so this is what we built over the summer. Glide Room is a little video conferencing app in your browser. It uses WebRTC, and there's no registration, so all you have to do, you go on the site, glideroom.com, and you click Get a Room, and then the next page loads, and you have a room, and all you have to do is copy and paste that URL and send it to your friends, and anybody who goes to that URL will automatically enter the room, and they can, you can use video chat. You can so you can see their video, you can hear their audio, and there's also a chat. Right? We call this Hangouts without the hangups because we don't have to register and all that. Install a plugin and all that weirdness. Okay. A little bit about the architecture. So the front end is completely built with Polymer. So all component-based architecture. The entire thing is all custom elements. So everything that's on the GUI is even some non-GUI elements are custom elements. We try to make them all small and focused and reusable. All the elements have a well-defined public API that they interact with, and they communicate via events, right? So none of the elements actually know much about each other. There's a glue code that wires them all together, but all the elements by themselves can be used independently of each other. So if I wanted a chat window somewhere else in another app, I can just copy that element, I can just put it there and have a chat window, and I can hook it up. It's also written entirely in CoffeeScript, Jade, and Stylus. And we use Express, we use Harp, with Harp as middleware to deliver everything. This is how it looks like. I just changed the screen resolution so I wasn't able to adapt this. But this is basically what it looks like. So we have a toolbar at the top, right? This lets you switch on and off your camera and your mic. This goes to a little settings button, settings dialog where you can change your username. There's a chat button here which lets you hide the chat. So when you click, the chat just goes away, and then you have more space for the videos. Then we have in the main part, we have the videos, right? This shows all the people in the room, shows all the video feeds. And on the right side, there's the chat, right, where you can type something, click a button, it will appear, everybody else will be able to see it. And here's a little slider that you can use to change the size of the chat. The only core Polymer elements that we've used are the buttons. Those are from Polymer, and the slider here, this is from Polymer. All those buttons are Polymer, and the input for the chat. Those are Polymer from the Polymer component library, and they're all paper elements with some extra CSS, and the rest is custom. So the chat element, for instance, is completely custom. It's two elements. There's the chat view, and then inside of it, each message is another custom element. Okay, Now, how does this look like in the code? This is actually pretty cool. We're kind of proud of that. So this is the main page that shows you the room, okay? And you can see how for something, you know, that, well, complex, if we did this all with diffs, we would have 3 pages of diffs, right? But since we use custom elements, it's all custom elements and like 2 diffs for layout. And you can actually read it, and it's sort of descriptive of what you see. So first of all, we have a backend. This is a custom element. This brokers all the communication with the backend. So what it does is actually, you know, if there's a chat message, it will send a chat message to the server. All the server communication happens from the backend element. So all we do here is, so we load the backend and we can provide it a configuration file. The backend will load that file and then initialize itself automatically and then start talking to our server. And so for instance, when somebody, this is basically mainly for the chat, which is custom. So when somebody else in the chat room lives on the server, when somebody else writes a message, right? Their browser sends the message to the server, and then the server has to notify everybody, and then everybody else has to see the message, right? So the backend element actually polls the server. We're working on sockets, but it polls the server, and whenever there's a new message, it will just generate a DOM event that contains that message. Like I said, it doesn't know anything about the chat itself. All it will do is, oh, it's a new message, so fire an event containing the actual message, right? And then the chat element will be wired up to listen for those events, and if those events happen, right, if new chat message happens, then we tell it to add it. Okay? So then we have a div with vertical layout, right, which is basically the structure from top to bottom. So we have a toolbar, then we have the center area, right, which is subdivided, and then we have the footer. So that's the vertical layout, right? Inside the vertical layout, we have a toolbar, not surprising, right? We have a footer, and then inside, in the middle, we have a div. The div is flex, so it takes up all the remaining vertical space. The layout inside of it is horizontal, right, left to right. So we have the chat view, the video view, then we have the divider, and then we have the chat. So we see there's a core splitter. This is a Polymer element, right? We have a core splitter in the middle, and then we have the conference to the left and the chat to the right. And in our JavaScript, and I know I said it's CoffeeScript, but I know some people hate it. I made this so everybody can understand it here. So in our script, this is an excerpt, of course. This is not the entire thing, but this is basically our glue code. This is how we wire things up, right? So when Polymer is ready, everything is wrapped in there. This initialization is done once all the elements are upgraded, right? So we can, you know, the chat, for instance, the chat element. Oh, here, this is the one I talked about. So the backend, right? The backend gets an event listener. When a room event happens, then we let the chat message know, the chat element know, right? So we add it. So chat.addMessage. That's the public API of the chat element. That adds a new message. So then the chat element knows, oh, there was a new message. So now the chat element can decide what to do with it. In this case, that means it will add a new custom element and put the message inside. And then the custom element that contains the message will actually decide how it looks like, because as you can see, we have several types, right? We have events, like something happened, somebody entered or left the room, and we have actual chat messages, and they look different. But they're both the same custom element, just with a different data attached to it. And then let the conference process it too. This is so inside the conference element, if somebody leaves, we have to remove their video feed. So we have to remove that feed, and then we have to re-layout it, right? Because we will change the layout. If there's 3 people, we'll show them in a row. If there's 4 people, we'll show them in a square, and so on. And that's it. I have a couple links for you guys. Are there any questions before I get to that? We have about 4 minutes.
Can you quickly describe how Polymer is better than React?
I don't actually have much experience with React, so I don't think I can answer that. I looked into it. Maybe I'll be able to answer it next time. But I think React does not do anything custom elements at all, right? It does. Uh-huh. My understanding was it's just a very fast way to update your DOM with, like, it has sort of a so to make your DOM, keep your DOM in sync with your data.
Yeah, it also has a JSX language that allows you to create custom components, but it uses a virtual DOM instead of a shadow DOM. It's less standards, more kind of creating a layer on top of the standards instead of trying to become the new standard. So,
right. Is that so? That is that virtual DOM is implemented in JavaScript then?
It's pure JavaScript.
It's pure JavaScript. Is that reasonably fast? I mean, I hear it is. This is what Facebook uses, right?
very fast.
It's there, but there's been some demonstrations, like especially at the Ember community with HTML bars in comparison to React.
Yeah, I hear they chose to adapt more React style stuff, right? So it'll be interesting. I guess they'll.
Not necessarily that they did HTML fragments. So HTML fragments are just you create your document elements in your JavaScript, and you just say declare the root element as a fragment. So when you go to insert the DOM and all that, it just it's like creating DOMs in JavaScript almost essentially without dipping like what React does. Because React does dipping when it updates the DOM. So it's like you make your changes and then it has to go through and update the DOM, and they're taking more of a direct approach, so they kind of skip that whole step.
Okay, that's pretty interesting. That'll be interesting, I guess. So that means now, I mean, they're already on sort of different paths, but now they're even more divergent paths. If Ember is, I mean, they're basically the two most serious frameworks left right now, I think, like Ember and Angular, right? Backbone's sort of still there, but I think it's a bit of a niche thing, right? Because it doesn't really do anything about the view and lets you figure it out yourself. Suppose you can do, I don't know, can you do that? You can do Backbone. I suppose you could do Backbone with React or something.
Or underscore.
Yeah, underscore is already built in, right? It's the same guys. It's the same guys. So they actually, it depends on underscore, but it doesn't have a template technology. It doesn't have anything for that, which is good because you can choose it yourself. But it's also not good because a vital part is missing. Another question?
Have you looked into like what will be the impact of ECMAScript 6
Have I looked into what will be the impact of ECMAScript 6 on Polymer?
on Polymer and also the browser rules?
Not much because it's backwards compatible. So the code right now, this is all written in ES5, so it will still run, right? And what will be the impact? I don't really see that. I don't see that there's any. It doesn't hurt, right? Like what's the impact? It'll let you write more powerful code, like so you can write your the code inside of your elements. You could write that in ES6 once you know the browser is going to understand it, right? For the time being, on the front end, it's probably better to stay a little bit conservative and run with something that'll work, or you'll have to. You have to add another build step before you deliver your custom elements and tracer compile it back to ES5, right? Which is also possible. But I don't think there's this sort of orthogonal, I think. Because this is just a set of APIs that live in the browser, right? This extends the DOM APIs, and it lets you do different things with the DOM, but it doesn't really specify how you do it. Or with what language, right? You can write. There's pages, there's communities. You can write Polymer with Dart, right? There's sites that show you how to do that. Obviously, Google is also sponsoring that, right? Because they're sponsoring Dart. So there's, you can write your Polymer elements with TypeScript if you want, as long as you deliver it in browser compatible JavaScript. It's really up to you. ClojureScript, if you will.
How
Yeah.
stable is the Polymer API now?
It's still pre-release, and it's changed quite a bit in the last 6 months, but it's probably getting better. So they're now at 0.5, version 0.5, and of course everything before the big 1.0 is to be treated carefully, right? And things might change and might break, and in fact they did break a few times as they decide to, as the library matures, right? So it's the whole thing. The good thing is the whole thing is on GitHub. It's open source, all of Polymer. You can file pull requests. They're pretty responsive. We had a couple bugs that we discovered while building glide room some of the elements weren't behaving as the specifications said that they should be. You know, we filed bugs on GitHub and they got fixed. So they're very active, and Google pays a bunch of people that work on it full time. But yeah, as it slowly matures, they still make some changes that sometimes break. For instance, there was for a while they couldn't figure out if they had an icon button, and they had a button, and they had icon. Hang on, I'm going to try to get it back. So they had there was an element that just showed an icon, and there's an attribute that you can. It's an SVG icon, so it's scalable, and there's an attribute that you can tell it which one. So you can say, let me get this back. You can say core icon, and I don't know, an email, or send something, or save, or something like that, and it would show an appropriate icon. Then there was a button. Then there was then there was an icon button, which is a button with an icon. But you can also get that by just using a button and putting an icon inside. So there things like that. They're trying to figure out what is the best way to do that, right? What is the most sensible and extensible and meaningful way. But it's been pretty stable overall. Let's see. All right. I got a couple links for you guys. You don't have to write them all down. I think the presentation will be online. It should be linked from the page. There's another question?
Yeah, quick question. Thoughts on data caching or data storage on your client?
Data storage. Well, so HTML imports are cached just like any other site assets. So just as if you would include an image, it's cached in the same way.
I'm thinking data, so I'm thinking mobile app.
Offline storage?
Offline
Thinking
storage.
closer to like phone gas, I guess.
Say that again?
Closer to, I was thinking what you might do with phone gas or
Something, yeah.
local.
Yeah. I'm thinking like a SQLite, but I know that some of those standards are kind of not standard. I just want to know how to do this offline also, so that I'm thinking in terms of devices that are offline for a while, so my app still can work, so if I'm building an app that works equally well on the web or not. You're looking at it with like...
Oh, okay, okay. So once the app is loaded, it depends on what requests it is making, right? So once all of my page is loaded and my elements are loaded, then it's all up to what those elements are doing, right? So you could use, like HTML5 storage API or something like that, and build your backend so that if the server isn't available, like in this case, right? I think I don't know, but that seems like a pretty good idea to encapsulate all your backend in one element. That way, inside of your app, you can talk. It's all standard DOM stuff. Like you can send events back and forth and make public API calls, and then your backend can broker all the communication with the server. And so you're free in that backend, obviously, to change things around and say, oh, if the server isn't available, I'm gonna store the stuff, right? I have a queue inside of HTML5 local storage, right? And then once the server comes back on, then I work off that queue, right? So your backend could start working off the queue in the background, unbeknownst to all your other elements, right? They could just keep working as normal. So you can do that, right? So that's the interesting learning, is that your custom elements obviously don't have to have a mini DOM, a shadow DOM. They can have no interface at all. They don't have to even have a template, right? They can just have, and that's another interesting part of it, that they can just have behavior and no user interface as well. And in fact, the core library also has some of them. There's an AJAX element that you can use to declaratively make AJAX calls and load static files or something, things like that, right? So there's actually a variety of elements in there that do that.
It's a lot, I would argue, so it's a lot more complicated than that, because you run into the situation where items are modified in multiple locations at the same time.
describe is obviously one level, but you can go a level or two deeper. I'm kind of getting into an area where we have an open source project.
Where levels are, that sounds like synchronization, but that's synchronization. Obviously, Polymer is not about synchronizing. It's not about synchronizing data. Well, I guess it's synchronizing its own state with the DOM, right? Like, so your elements have to sync, right? Like the two-way data binding and stuff like that. Yes, but obviously it doesn't. It's not. It doesn't pretend to solve your own data synchronization issues, right? Like that gentleman said too, right? With what if my backend goes offline or so, right? My server connection isn't there. Can I still use it? Yeah, of course. Once, I mean, if you work off that queue also, right? Like, yeah, you could get into synchronization issues again, right? I think that's a whole different problem.
Would it be fair to say that Polymer is about the presentation and DOM manipulation? It doesn't have any opinions or tooling about server-client communication. That's like a separate.
None at all. Yeah, none at all. It's just about front-end stuff, and for that it just leaves you. Yeah, it leaves you. You can use any server technology that you want. You can use Ajax. You can use Sockets.io. You can use all the stuff. There's no. Polymer doesn't have an opinion on it, right? Or even web components, right? You can build your own components to encapsulate any other API, anything else. All right. I think it's time to stop. Thank you guys all for coming. Come visit us on the web, pandastrike.com. And enjoy SCaLE.